Hello and welcome to my YouTube channel. This is Jonathan Goldfish. Be sure to like, share and subscribe to my YouTube channel. Thank you for your support. Hello guys, welcome to my new YouTube channel of the Jonathan Goldfish Education, and this is Jonathan Goldfish. So, the main purpose of creating this new YouTube channel is to give back to the A-level society. And here's a candidate who has recently finished A-level examinations. So not only to give back to the society, but also to give back to the to cultivate the next generation of A-level students. So for today's video, we are going to discuss the CAIES level and A-level mathematics, basic mathematics 9709 without the nonsense. And let's go through what you will learn. What do you learn in your basic mathematics through the AS and A level? These two phrases in your entire A level. So, in basic mathematics, it consists of the six papers, but each student only takes 4 papers. Okay? In your AS level, you are going to take Pure Maths 1 and your Mechanics. Alright? For A2 level, you are going to take the Pure Maths 3. Pure Maths 1 and the Statistic 1 is your AS level. Pure Maths 3 and either Mechanics or Statistic 2. Or you can take both if you want. Because I'm indeed a Malaysian. And since this is my first voice review, and I also admit I'm as a Malaysian. Alright? So I'm not going to talk too much about my identity, and please refer to my original Jonathan Goldfish YouTube channel for more details. Alright? And this is the educational YouTube channel. It's only for A-level discussion. So in this video, we are going to go through what you learn from your Pure Mathematics 1. In your Pure Mathematics 1, it covers 8 chapters, 8 chapter syllabus. So what are the 8 chapters? 8 chapters are quadratic function, coordinate geometry. I've been abbreviated, and please refer to my subsequent videos, and I'll upload these chapters later. Circular measure, trigo function, and series, and the 2 calculus, which is the differentiation and integration. But these 2 calculus are just only basic, the basic calculus only. Okay, I believe most of these syllabus you have learned from your secondary school, such as XPM, IGCSE, or O level. Okay, and the syllabus of these 3 are equivalent. So let's proceed to our first chapter, quadratic. In this video, we are going to enter first chapter of the Pure Mathematics, Basic Mathematics, Pure Mathematics 1, which is your quadratic. Okay, so in this chapter, what is your learning outcome from this chapter is to carry out the process of the completing the square of this general quadratic polynomial. Okay, it considers as the polynomial equation because it consists of the x and x squared, and use the form to locate the vertex of the graph to sketch the graph, and also to solve the quadratic equation in one unknown for this subtopic. Alright, so let's enter the first subtopic of this first chapter. Given that the general form of the quadratic expression is y. Why we need to denote y? Because y denotes the quadratic function that equals to ax squared plus bx plus c. And what are the conditions? Ya can be 0, because if you let the coefficient of this x squared become 0, it doesn't consider as the quadratic function. Alright? And b and c is not can be not only 0, and it also can be the they also can be the all real numbers. All right, any real numbers for B and C. Why A can't be 0? Just now I've told you the reason. And the other conditions or the best evidence to prove that the given equation is a quadratic equation is to see a term with the highest power of 2 of the variable x. Okay, it's known as the quadratic equation. Okay, because since this chapter only you will only learn how to solve quadratic, how to identify the equation, whether the equation is quadratic, and then to how does this A, B, C vary in your quadratic functions graph. All right, let's take a look before we proceed to the completing the square. Let's try out this question. Identify which of the following expressions are quadratic expression and give your reason. So, in your first equation, the first expression, is it a quadratic expression? The answer is yes. Why? Because the highest power of the in the term variable goes to 2, and this is the essential condition to verify that this expression is a quadratic. Okay, so we can write yes because the highest power goes to 2. But of course your actual exam won't ask you this kind of question. Okay, this is for you to understand which is the quadratic equation based on their characteristics. All right, okay, let's take a look at the second part, the second expression. Okay, many candidates thought that this is the quadratic expression. Now, because you see this is seems to be like a reciprocal, but the reciprocal of x, its function below denominator has replaced as the quadratic expression, despite the denominator function is replaced as the quadratic function, but this entire reciprocal is still not considered as the quadratic. What is the reason? It's simple. Because imagine if you let this become the y, okay? It is let's represent the x squared plus 8 is your fx of y, and you can see that one of xx is obviously not not a quadratic because this the power of the function is only -1. Okay, not 2, because the 2 is already inside the reciprocal. The x squared plus 8 is inside the is under as the denominator as a reciprocal. Okay, many students will realize that is a quadratic equation. So this leads the some of the candidates make a careless mistake. So please aware that. Okay. And let's see the third one. Yeah, of course, this is the 4x minus 8 is not a quadratic equation. Why? Because you see the 4x, it is obviously to prove that the highest power of a term only goes to 1. Okay? That's why the 4x minus 8 is not a quadratic. Okay? So in this part, you will learn how to identify identify a quadratic expression or quadratic equations based on their characteristic of the equation. Okay, and after you have learned about this, let's proceed to the next part of this subtopic, which is how to convert the general form into the vertex form. There is an only method, which is the completing the square. You can also abbreviate it as the CTS. Alright, from now on, I will abbreviate it completing the square as CTS. So next time, when when you are discussing the past year, I will only say CTS. Then you need to realize that CTS denotes completing the square. Alright, this will save our time for the discussion of the past year papers. Once I have finished all the discussion of these 8 chapters. Alright, how does the CTS carry out? You see there's a general form. What is the first step? Okay, the first step that to convert this equation into the vertex form, which is a, this is the general vertex form, which is a bracket square of the x minus p plus q. So what is the advantage of the vertex form? Actually, vertex form helps you to identify its turning point of the graphs of the quadratic graphs of its quadratic function. Okay, of its graph lah. Okay, where this PQ is your turning point, whether it is a maximum point or minimum point. It depends on your A. Okay, A means the polarity. This one will discuss later. Okay. No. No, this is the function. Either we'll discuss later or in the subsequent video, which is your next chapter, which is function. Okay. So your first step is factorize your A factor out in order to let the entire bracket inside the x square, the term x square in the entire bracket inside becomes 1. I mean to let the coefficient of x square becomes 1 in this inside bracket. Of course, the coefficient of other term need to divided by a. Alright, in order to satisfy its equality. And next, you need to divide the you need to add or minus b over 2a. Sorry, I missed this. I mean this entire divided by 2. And bracket square minus the another in order, and also in order to satisfy its equality. Alright. So what is the purpose of the b over 2a? Actually, the b over 2a denotes the axis of symmetry about the quadratic, the graph of the quadratic function. Okay, so that you will simplify and factorize this easier into this form, x minus p and bracket square, and the another side one, which is your q, and then you expand back your a, okay, to obtain your q. So this is how you convert the general form of the quadratic equation into the vertex form, okay, to identify the turning points. Alright, so I'm not going to discuss too much in here. Let's proceed to the next part of this subtopic, which is how to solve a quadratic equation. There are 3 methods. First method is the factorization, when this quadratic equation can be factorized. following depends on the possible sum of the roots and the product of the roots. Okay, this one you also learn from your secondary school, which is sum of root SOR, POR, POR, product of root. That means your B is the sum of roots and C is your product of roots. So for example, you see there is a 6, negative 6, right? So what is the sum of the negative 6? It could be negative 4 and negative 2, right? So for the 8, it also could be negative 4 times negative 2, or 4 times 2, or 8 times 1, 1 times 8, or negative. Okay? And then you find which possible sum and the possible product satisfy each other. So obviously, it's negative 4 plus negative 2 and negative 4 times negative 2. So obviously, now it also could be 4 plus 2. Okay? So overall, only this and this to be satisfied. Okay, with this negative to find your roots. That's why the question wants you to solve. The meaning of solve is to find the x from the quadratic equation. Okay? By this through this factorization. To find the possible sum and product of roots that are satisfied each other. Okay? And the next method, if you can't if you feel that factorization you are not able to carry out the factorization, you can use the second method, which is CTS. Okay, how does CTS perform to find your x from a quadratic equation? So you are given this equation, make sure that your quadratic equation equals to 0 before you solve it. Okay, I forgot to add on another step. Let your quadratic equation equals to 0 to find your x. Alright? So first thing first, for the CTS method, you move the constant to the right hand side. Okay, this is your first step. Second step, add the b over 2. I mean b over 2a lah. You assume that there's an a as the coefficient of the x squared. So that's why I want to emphasize that you need to add b over 2a and then bracket square at the both side. And then in order for the equation of the left hand side to completing the square to factorize it easier. Alright? And then you also need to evaluate the values at the right hand side. And then you can factorize into the square form easier. Take square root on both sides because of the quadratic has the highest power of the two of the term x. That means fundamentally the quadratic equation must have two solutions, which is two x-intercept to the x-axis from this graph of this quadratic function, quadratic equations. Okay, you need to carry out plus or minus. You need to consider plus or minus. Why? Let's say you are given a perfect square 4. I square root it, radically becomes 2. But you can also consider that 2 square is 4 and bracket negative 2 square is also 4. So that means you need to consider positive or negative. Okay? However, for this case, this is only square root 4, not negative. So we only consider positive because this is a radical square root. Alright? So these are the common mistake that is made by the some candidates. Alright? So there are the third methods, which is the quadratic formula. Okay. So this quadratic formula actually exists from your formula booklet MF19. Okay, later on I will upload the MF19 in my Google Drive that is located in the description below of this video. So from this quadratic formula, you have negative b plus or minus the square root of b squared minus 4ac divided by 2a. So how to indicate whether your roots are real roots or no real roots? It depends on the discriminant. B squared minus 4ac. This one you will learn later, which is the nature of the roots. Okay? So how does the quadratic formula come from? Actually, it is completing the square of the general form. Okay, given there is a general form, ax squared plus bx plus c. Okay, the next step is to move your constant to the right hand side. Divide a and all at both sides, and then add the bracket square b over 2a at the both sides as well. And then you simplify this at the right hand side and completing the square at the left hand side. Now you have b squared minus 4ac over 4a squared. So you have already obtained this discriminant, and then take square root at the both sides. Remember to put plus or minus. Alright. And then eventually you move this b over 2a to the right hand side. And you have proved this quadratic formula from the general form by carrying out the CTS method. Alright. So if you're using the quadratic formula but your real roots are in the integer, it's because of the discriminant is perfect square. Okay, let's take the third method. Let's say you have the x squared minus 6x plus 8. So identify your a as 1. Okay, because the coefficient is 1. B is your negative 6 and C is your 8. Now you apply the quadratic formula. You have negative 6 for B, negative 6 squared, okay? Of course you need to bracket inside, and minus 4, this is 1, and C is 8. Divided by your 2A. So here you simplify as 6, here you have plus or minus, here you have 2, and use your calculator. So this is negative 6 squared, which is 36. So you have square root of 4. So you can see for the integer roots, your discriminant is a perfect square. And now you simplify this square root of 4, which is 2. And then you also found the same answer as the completing the square method above. Alright? It is acceptable if you use the quadratic formula, okay? Because it gives you convenience in solving the other involving the quadratic equations. So this quadratic formula can be used in physics, other application in mathematics, for the mathematics, or in the mechanics for the mechanics like that. Okay, so So if you master this, it gives you many advantages of solving other mathematical applications questions. All right. So next is to discuss how does the vertex form of the quadratic equation vary in the Cartesian graph. Okay, as you know, as I mentioned for you, the general form of the vertex form is a bracket square x minus b and plus q, where pq is the coordinate of the turning point. And now it's time for us to discuss the polarity, the sign of the a. So when a is positive, it is a smiley face, which means this quadratic function has a minimum point. If your a is negative, it is a this quadratic function has a maximum point. Okay, the turning point is the at maximum. Meanwhile, for a is positive, its turning point is the minimum point. Okay, so what are the methods for you to remember the sign, the sign of the a as the coefficient of the x squared? Change with the graph. So a is positive. Positive means you're happy. So this is a happy face. A is negative. Negative means sad. Sad face. So this is the best method for you to remember and identify what does the how does the shape of the quadratic function look like in the Cartesian graph. Okay. So how to sketch a graph of the quadratic function? The first you need to identify whether a is positive or negative. Okay. Second is to find the turning point by CDS method. This method is necessary when the given necessary. This method is necessary when you are given only a general form, and you need to convert to vertex form when it is a vertex form. Okay. The third step is to find the y-intercept by let your x equals to 0 to find your y-intercept. So here is a y-intercept, which is your c. Okay, the c from the general form. And next, this is the x-intercept by letting the y equals to 0. Of course, this you need to master from the discussion above, which is like the same method as the solving the QE by letting the y equals to 0. Okay, and then you will sketch the graph easier. You have x-intercept, y-intercept, and turning point. These three things are enough for you to sketch the graph of the quadratic equation. All right. So let's proceed to the next subtopic, which is the nature of the roots. So the nature of the roots of the quadratic equation, how to identify it? So you can use the discriminant that I discussed just now from this quadratic formula, which is b squared minus 4ac. So how to use this discriminant to determine that whether any quadratic equation has two distinct roots, real roots, two equal roots, or two complex roots. But in this syllabus, it only considers that the complex root are not a real root, no real root. Okay. So there are three types of nature of the roots, which is two distinct roots or different roots, two equal roots, and two complex roots, aka no real roots. Alright? Provided that your two roots has the term I. The I refers to the square root of -1. This is the complex number. This one you will learn in your A2 Pure Mathematics 3, Chapter 9, which is your last chapter of the Pure Maths 3. Complex numbers. But in the syllabus of the Pure Maths 1, we only consider complex roots are not a real root. Alright? So there are two distinct roots of the quadratic equation when your discriminant is positive. Which means when your quadratic graph keeps shifting downwards, your discriminant is always positive because you keep decreasing your C. That means the entire must be more positive. Okay? If your discriminant is your discriminant is exactly equal to 0, which means the quadratic graph is only intersect at one point at the x-axis. Okay? Two complex roots means that the quadratic graph won't intersect the x-axis either. Alright? So this is how you identify the nature of the roots from a quadratic equation given. Okay. So let's proceed to the last part of this first chapter. The last subtopic of this first chapter, quadratic. Which is the quadratic inequality. Before I enter the inequality, I'm not going to go through this inequality for you. You need to read through by yourself. And this note later on I will upload inside the Google Drive for you to refer. Alright? And the exercises below, I'm not putting too much because basically the most of the exercise come from the textbook exercises. Okay, here is your textbook. Let me find for you. Yeah, these exercises. However, I will discuss with you later. These all exercises below. Okay? So let's see. If you are given this quadratic equation is greater than 0, but this inequality sign has no equal sign. Alright, you need to take note about this. Greater than and the equal are different. So that means the quadratic graph, the range you need to find, of course, is greater than 0, which is under the quadratic graph. Okay? So what are the possible sets of value? Okay? So when this quadratic function is greater than 0, what are the possible set of value? But in secondary school, it asks you range. But this time, the question changed changes its phrases, the changes the tone of the question, the asking. So eventually, you need to give x less than p, provided your x cannot be p, because the question wants you to find the center value for the um, for the possible roots when this quadratic function is greater than 0. So these are the possible roots except the p and also the q, because pq are the x-intercept of this quadratic equation. And in between p and q, you obtain the negative range. Okay, this is so called the range. Range means the y lah. Okay. And for the quadratic equation, the quadratic function is less than 0, so it the x lies in the negative interval, which is p to q. But the possible solutions cannot be p and also cannot be q in order to satisfy this inequality, same as the above one. So yeah, we have finished. Before I end this chapter to proceed the exercise, I need to tell you this application. So of course, this quadratic equation is applicable if you want to solve the simultaneous equation with the linear, of the quadratic with the linear, is to uh, set these two equation and then solve simultaneously by using the substitution method or any method you want. But I think it's only substitution. Okay, eliminate any term and then you solve. You must get a quadratic equation and then you factorize completing the square, and anyway it's just solve for any variable, but then you should have the two solutions, two intersections of the line with the quadratic with this quadratic graphs. Okay, I mean the two intersections of this linear line with the quadratic graphs. Okay, so I have end my discussion of this chapter 1 quadratic. Let's move on to the exercises. Alright, let's move on to the exercise for this chapter 1 quadratic before I end my video. And this is the first question, which is a past year question, 9709 ON 2002, question 11, paper 1. This is only the first part because somehow the other parts of the questions do not involve quadratic, somehow involve the subsequent chapters behind this chapter. Okay, so let's see the first part. Express 2x squared plus 8x minus 10 in the form of a bracket square of the x plus b plus c. Okay, I will give you 3 minutes time for you to complete this question. Nah, just kidding. You can pause this video and I will show you the workings. So given there's a 2x squared plus 8x minus 10. So based on this, you need to factorize the coefficient of the x squared first. So you need to factorize 2 out. Okay? Make sure your coefficient of x squared becomes 1 inside the bracket, and 8 over 2 is 4. 10 is 5. Next step, you need to add plus and minus of the bracket square of this 4 over 2. Okay, or b over 2a. That means you need to divide it by a first and then divide it by 2 and bracket square plus or minus in order to satisfy this equality. So I put square bracket x squared plus 4x. So this part is important, which is plus 4 over 2 square minus 4 over 2 square and minus 5. And now 4 over 2 is 2, 2 square is 4. So this is already a complete a square, a perfect complete CTS factorization. So this part you will have x plus 2 squared. Okay. And then for the another side, there's a 4 over 2 is 2, 2 square 4, negative 4, negative 5, you get negative 9. And also you need to factorize back your 2. Negative 9 is negative 18. Okay? So the answer for this expression of this general form into this form is 2 bracket square of x plus 2 square and negative 18. Okay, this one you should obtain 2 to 3 marks. Alright. Let's see the next part of these subsequent questions. So these questions are mostly from the textbook lah. So I won't discuss with you too much here. So let's solve by factorization. I will only discuss about for 2 questions. So let's solve this first. A, you have x squared plus 3x negative 10 equals to 0. I think I have to go through with you about F, A and F. And the rest you can try by yourself. So let's carry out the factorization to find your x. As I told you before, 3. What are the possible sum of 3? 5 minus 2, correct? 5 and minus 2. And the 10 can be also 5 minus 2 or minus 5 times 2. Or could be also 10, 1, 1, 10. 10 negative 1 and 1 negative 10. Also, alright? So, which part, which possible sum and possible product of roots satisfy each other? So obviously it's a 5 plus negative 2 and 5 times negative 2. So you can factorize as okay, you need to put 2 brackets and you give x and x. And you can put 5, 2. Alright? So, of course, the 5 must be in positive. So you put plus here. And you also put negative. After you found the possible root, you need to say x because this x times x squared, this one times x is x squared, and this one is no, this one is a positive 5 and negative 2. Okay, because I want to let the sum of root become positive. Alright. Oh, sorry, this one is a negative. So if you want to use the factorization, you need to think about the sum of root and possible sum of root and product of roots, which are satisfy each other. So this is how you carry out your factorization by guessing the possible sum of root and product of root. SOR, SOR and POR. And now you separate into two cases to find your x. So eventually you have two answers for the x, which is x equals to 2 and x equals to -5. Okay? And I will solve the f. I don't tend to discuss b, c, d, e for you for too long. But if you have any question, just ask me lah. Ask me through WhatsApp. So let's see the f. This step has an extra step, which is you need to expand the x inside in order to let the highest power of this equation comes to 2, which is 10x squared and -13x equals to 3. Next step, you need to move the 3 to the side of it in order to become a quadratic equation. Alright, and you must carry out the factorization. Okay, so put two brackets here. C, what are the possible product of -3? Is 1 times -3. What are the possible of this, the product of 10, which is 5 times 2, right? Or 10 times 1. Okay, 10 times 1 or 5 times 2. So for me, I will assume I will put 5 times 2 lah. 5x and 2x here first. And then this you only have 5 times 3, okay? Okay, you see the sum of root could be -15 plus 2. Or 2 minus 15. Okay? But you see, 15 is the product of 5 and 3. So here, of course, it's only 3. And here will be 1. Like, solve it in this way. If you are not able using the factorization, but you don't think you need to use the quadratic formula, maybe I will teach you the technique of using the calculator. If you have this Casio calculator FX570EX. So I will post the tutorial of using the Casio FX570EX in my next video. Okay? So please stay tuned for my next updates. So let's put the sign. Obviously here you have negative and also you have positive. You need to let the b becomes negative, right? So 5 times 3 is -15 and 1 times 2x is the 2. So -15 plus 2 is -13, which makes sense. Okay? And next you separate it. Into two cases. Move to the other side. And finally you will get x equals to -1/5 for the first root. The second root, which is your 3/2. Okay, here you have the two roots already. So this is how you carry out the factorization. So why does the question here not including the solve by using the completing the square? Because quadratic formula is basically derived from the general form by using the completing the square. So for this quadratic formula, I will only discuss one of these 6 part of the questions, and the rest of the 5 questions you need to do it by yourself. So I will only extract this e. Let's solve the e. Identify what is a, b, and c before applying the quadratic formula from your MF19. Okay, quadratic formula is available in your MF9 in the MF19 that is given in your actual exam. Your A is 4, your B is 7, and your C is 2. Okay? And next, using the quadratic formula, which is negative b plus or minus b squared minus 4ac divided by 2a. Substitute ABC inside the quadratic formula. Make sure it's 7 squared. Okay? 4 and 2. So, if you see the statement, if you see the question, the statement of the question behind, give your answer correct to 2 decimal place. Then you need to aware that the discriminant of this quadratic formula is not a perfect square. Instead, it is a surd. It is a surd form. But this question wants you to give your answer, I mean the x, into 2 decimal places. So let's simplify the discriminant first. So 7 squared, 49. Minus 4 times 4, 16. 16 times 2, which is your 32. So you have 17. So 17 is of course not a perfect square. And 2 times 4 at in the denominator is 8. Separate in the two cases, negative 7 plus 17 over 8. And another case is for the negative one. I mean the negative for the another case. Now you press your calculator. And for the first part, you will obtain negative 36 because your answer need to round out to 2 decimal place only. And for the another cases, another negative for another cases is negative 1.39, also 2 decimal place. And voila, you have solved this quadratic equation to obtain your x is in the 2 decimal places. Okay. So let's proceed to the next part. I will write 1, 2, 3 lah. For this part, it involves the questions of nature of the roots, but on the account of the time, I need to squeeze my time to solve one of these 3 questions, and the rest you need to do by yourself. But if you want to do more exercise, you can refer to the course book. Okay? To the course book. I will also upload the course book in my drive, and you may access to the drive. Okay? And I will extract, maybe I'll extract the third part. So find the set of value of m which the line y equals to mx plus 5 does not meet the curve. So you have y equals to mx plus 5. This is a linear equation. Okay, for the given unknown m, x squared minus x plus 6. So you need to solve the simultaneous equation. You need to let y is equal, okay, to find the intersections. Not intersections, is to find the set of value of any unknown with the characteristic of when the line between the line and this curve, this quadratic curve, Okay, because quadratic graph is a parabola curve. Let this become equation 1 and this one become equation 2. For this y and this y, you need to let them become equal, so you write 1 equals to 2, which is mx plus 5 equals to x squared minus x plus 6. Move the mx and 5 to the right hand side. So this is negative x and negative n. So you have the plus negative 1, negative n, x, and 6 minus 5 is 1. Like this. So you must also read through the question carefully. Does not meet the curve. What does it mean? It means that you need to consider about discriminant. So you can see this line does not intersect the curve. That means your discriminant must be negative because these two simultaneous equation has no real solutions, right? So you need to let the b squared minus 4ac become negative. So here is a b. Identify ABC from these quadratic equations. So your b is negative 1, negative m squared. A is 1 for sure, and 1 for c. So you can see negative 1, negative m. You can factorize and square it up to become positive. So basically, this is the square of m plus 1. So you have m squared 2m plus 1. And also you have negative 4. So you here have m squared plus 2m negative 3. So the purpose of learning the quadratic inequalities is to find the set of values of any unknown. So for this question, the unknown is m. You need to find the set of value. So always you can draw a line, a quadratic curve. So here are the two roots. Now this quadratic equation seems to be like factorizable. Okay, you may factorize it. So you can factorize into m minus 1 and m plus 3. So if you let this quadratic equation become equals to 0, you have negative 3 and 1. So the interval for this quadratic equation, let's say this is your m and this is your function m, which is a quadratic function of the m. So it wants you to find the set of value where your range must be in the negative interval. So your answer should be put between 3 and 1 for the set of value m. So this is how you give your answer of set of values n. So set of values n mostly is inequality. But for this question, of course, set of values of m denotes range or interval. Okay? So the rest of the two questions, you need to do it by yourself. So let's proceed to the challenging part. This okay, for the challenging questions, you may do this by yourself. Okay, so we are only discussing the partial questions. So this is the combo version of this entire chapter 1 quadratic. So here you have the equation of the curve is y equals to x squared negative 3x plus 4. Okay? So for the first part, show that the whole of the curve lies above the x-axis. So how to show that? Of course, you can directly apply the completing the square lah. Identify your A is 1, your B is -3, and your C is 4. Carry out the B square minus 4AC, okay, to test that its discriminant is positive. So just substitute inside, then you'll find it. This is a 9, 16. Yeah, it confirms it is a negative. So you have -7, which is less than 0. Okay, since you can say that since your discriminant is negative, so the curve lies above x-axis. So the discriminant has shown that the entire curve lies above the x-axis. So shown. Alright, let's take a look at the third question, because somehow the second part of the questions must not be the quadratic. So this is not considered as the jumbo questions. Okay, so the equation of the line is, let's proceed to the next part. The equation of a line is y plus 2x equals to k, where k is a constant. Then let's check the third part. So let's check this third part. In the case where k equals to 6, find the coordinate of point of intersections. So let's substitute the k inside. Y plus 2x equals to 6. Let this become the first equation. And the question wants you to find the coordinates of the point of intersection between the line and the curve. So you need to let the second, the quadratic, the curve equations becomes the second equation. And then you need to substitute 2 into 1. So you have x squared -3x plus 4 and plus 2x equals to 6. Simplified, move and simplify as the quadratic equation. So you have x squared -x and -2. Okay, I will use the fastest method, which is factorization. X minus 2, x plus 1. So 2, the -2, the product of negative 2, I will put 2 times 1, but the sign is 1 -2 to get the -1. Okay, and then eventually you get your x is 2 and -1. Okay, next you need to substitute. You need to use the shortest possible time. I mean, use the fastest way to obtain your x and y. So for the first one, sub x equals to 2 into your first equation. Okay, so that you don't have to calculate, you don't calculate much to waste your time. Okay, this is the best tip for you to save the time for dealing with this question. So when x equals to 2, you get your y is 2. Meanwhile, for x equals to -1, you will get your y is 8. But is it the end of this part? I would say no, you won't get the full mark. Why? Because the question wants you to find the coordinates, so that in your final answer you need to rewrite as the coordinate form again. 2, 2 and the -1, 8. Okay, so the way how you write the coordinate of geometry, I believe I don't have to repeat again, because this is basically the basics of maths from your secondary school. All right. So in the case for the k is unknown, let's see the fourth part. Find the value of k for which the line is tangent to the curve. What is the meaning of tangent to the curve? Means that line only intersects one point with the curve. Only one point with the curve. What does it represent? Represent that your discriminant is equals to is exactly equal to 0. So in your fourth part, you still have to label two simultaneous equation. So for this is first equation. For the second part is equation 2. And for the same procedure, just that this time your k is no longer 6 for the fourth part right now. So substitute your second equation into the first equation. So you have x squared negative 3x plus 4 plus 2x equals to k. So negative 3 plus 2 is a negative x and 4 minus k. Use the characteristic above, like using the discriminant to find the value of k. So b squared minus 4ac equals to 0. Here you have 4 minus k squared and a and c, a 1 and c negative 1. So you have oh, sorry. I mean your b is negative 1, your a is 1, and your c is 4 minus k. Now you will find your k easily. Negative 1 square bracket is 1. And 4, negative 4, if you expand inside, you have the negative 16 and plus 4 k. Now it's time for you to find your k. So 16 minus 1 is 15. So eventually your k is 15 over 4. Okay? Where k is your constant. As long your constant is real is real. Okay? It's a real number. So I have end my discussion for this question. And the rest of this question you need to try out by yourself. So I declare that chapter 1 quadratic has ended. Alright, before it comes to the end of the video, let's summarize what you learned from this chapter. Quadratic. First, knowing the general form of a quadratic function, a quadratic equation, and identify whether the equation is a quadratic by looking the highest power of 2. Second, how to convert the general form to vertex form by using the CTS method. Third, to solve the quadratic equation by using the factorization and quadratic formula. But for the CTS method, it's not usual because the quadratic formula is already derived from the general form by using the CTS. Fourth, how does the vertex form of the quadratic function varying its graph in the Cartesian plane. Fifth, to find the nature of the roots, you need to it depends on the discriminant from the quadratic formula, which is b squared minus 4ac. Six, this is the finally part. This is a quadratic inequality. You need to see whether the quadratic function wants you to find its domain from the range required. Let's say it's bigger than 0. You need to find the domain which is above the fx. I mean above the x-axis, and otherwise it will be lower than the x-axis. Alright, so it comes to the end of this video. In the next chapter, we are going to discuss the next chapter, which is functions. Alright, the most important part in entire paper 1 of the pure mathematics. Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.